All right, we're now working on the Unit 6 code. Um, and I'm going to try to step through some of this and maybe do a little bit of explaining as we kind of work through it. Um, they have a lot of information about here about libraries, which, we've kind of learned about already, so I'm not really sure what the point of it is. I'm also making this observation that they said this lab should take 4 hours to complete if you're unfamiliar with the tools. And that you should be reading all this stuff. The first thing that they're going to do here in this first cell is they're writing a function, right, called vectorize, that basically will create vectors out of the words. And it's not really vectorizing them at this point necessarily, but it's taking all the words and putting them into a list structure. That's what this implies, right? And it's doing it, notice, without any libraries. We're just using native Python tools. And I think I mentioned that in like the video I recorded for Unit 7, that there are some things that we can do just with Python to do some of this stuff without using libraries. The libraries just make it easier. So what this will do basically is do that process. So it's going to loop through the vocabulary basically that we have set up, and then it'll count all the words and then return that. It's also looking for the uniqueness here in this one, and this one's setting up a set. Remember, a set is a data structure that's unordered, unlike a list, and it cannot have duplicate entries. Right. So it just whatever the total of words are. So we're looking for all the unique words. We're setting up some stop words. These are manually set, notice, right? So we're not using a big library of them. We're just picking which words they are, and there could be different ones. And then we're getting a list of sentences. So the first thing we should do, we need to run this code to basically build these functions, is what that's doing. All right, it's asking for a Python environment here. Oh gosh, and I'm not really sure which one to use today. Let me just go with my base Anaconda 3.127 rather than create a virtual. Okay, so now I think it's connecting here. So let's just wait. Turning on the Python environment, and now it's running the code, no problem. So it just built the functions, and now they're in memory ready to be used, right? Next, we're setting up the stop words, the special characters that we're ignoring, question marks, semicolons, periods, etc. And then we need to drop in some code here, and yet we're gonna cheat, by the way, and we're gonna look at the solution, right? So this is the student, this is the solution, and we're just doing this to kind of speed things up here because we could be here all night otherwise. So let's just kind of look here, and we need our code here and here. So here's the code for that. So we have string to lower, chat, you guys. And then we're going to split those strings. And these are just normal Python functions, by the way, right? And we should be able to run this pretty easily. So it did the splitting, converted everything to lowercase, and then split the strings into structures. And there's your output. Right? It basically tokenized the strings. And notice we didn't use any fancy libraries to do this. Python just did this for us. No fancy libraries involved. All right. Now we'll find the vocabulary, which is a set of unique words in the corpus. Also need to filter it since we do not want stop words or anything like that. I don't think there's any adjustment we need to do to the code there. We just have to run this. So let's do that. Okay. And notice how it built a set for us. This is denoting a set. So this next box, what they want us to do is basically traverse that code and output it. So we're going to do that like this. We're going to run a for loop. And did I not give you, I didn't give you guys this code, did I?
Mm.
So there you go. So the one I just put in goes up there. And then the for loop goes down here. I'm going to go ahead and run this one. That one worked pretty well too. And you can see it worked because we see the output. I'm moving on to the next one. This one here, and I'm just kind of bouncing between the solution and the not solution. Now we're going to print that out. We're converting the sentences into vectors. And that's got an extra D in it. And notice that vectorize is our function from above. Let's just go ahead and run that. And that worked too. And you see how it broke it down, and notice how it counted them and turned it into numbers. Right, so that worked. Right. And now the point that they're making, that was the bag of words the hard way. So in other words, we can use Python natively to create this data, right? What they want us to do next is to use the sklearn library to do the same thing. And let's come down here and just split the text. So they're giving us a long sentence, and then we're going to drop in this code. Oops, I didn't grab all of it. Sorry. Dropping in this code to split the text. Once again, that's a basic Python function, by the way. So that should work without too much difficulty here. And then, so it takes that sentence or this block of text, which is really long, by the way, and breaks it down into its sentences and puts them in a Python list. So it's sentence splitting based upon a period. It says here we would use the sklearn library to find a bag of words representation automatically. Account vectorize provides a simple way to both tokenize a collection of documents and build a vocabulary of known words, but also to encode new documents using that vocabulary. And it says you can use it as follows. Create an instance, call the fit function to learn the vocabulary of one or more documents, then call the transform as needed to encode each as a vector. So we need our code here. So we're going to go here and borrow it. Here is the code in the chat. All right, so this is going to import pandas and sklearn. And hopefully we don't have any dependency issues there. Right. And there we go, right off the bat. Right. And they said that was the hard way to do it, was to do it the Python way. Right? Now we're dealing with libraries again. All right, so let's see if we can figure out a way to fix this. Not All right, I'm going to solicit a little bit of help here. Not sure what happened there. So that's altering the code a little bit. I don't know if you guys are picking up on that.
Mm.
I'm going to choose accept. And now I'm looking at all the code that we just pasted in here. And it just, I think it just changed that line.
Mm.
Yeah, and it changed the method name here.
Mm-hmm.
So let me try running this. And it worked. Okay. So I think I'm going to back trace this here. Actually, it doesn't really matter. All right, so this will be the corrected version I'm saving it. And so all that code at the bottom here should be this. I'm going to move on. We're already about halfway done, by the way. Next task is to find a bag of words representation. This time do it for bigrams, right? Um, so we have to do all the bigram stuff here. I'm assuming we're going to have to make the same edit. So let me try it first, you guys, because I anticipate it will probably fail, right? And then I think all they did is just add get names out. Okay, and that worked pretty quickly. All right, now we're going to use the TF IDF thing to kind of do some more work here. So first, let's make sure that our libraries are in place. Good.
Mm-hmm.
And we're going to be working with 3 documents here. All right, so we're going to run that just to store the variables. All right. And then we're going to drop in our code to fix that stuff. So this is pretty straight ahead Python stuff generally. And so what this is doing is splitting the sentences based upon spaces in between words.
Mm.
You can see that one worked. All right, and then remember the vocabulary part. This is where we're just using set functionality to create unions between the 3 different sets of words that we're gathering. That should work pretty easily as well. So now they've taken all the unique words and combined them together. So these are all the unique words, basically. All right. Now we have the unique words. We need to convert the documents into vectors so we can pass the vectors to our machines for any computation. Let's go ahead and run that. All right, and that ran okay as well. Find the bow vector for doc2, and then we have to put in our code there. And it looks like, okay, so the first one is there, that worked. The second one doesn't look like it needs any changes, does it? It looks like the code's already there, so I'm just going to run it. And I got to make sure I'm on the right document here. I'm confusing myself. All right, I'm just going to run this one and see what happens. Okay, so that's good. For doc 3, it looks like the code's already in there, right? Is it for you guys too? It says your code here, but it's already there.
Oh yeah, yeah.
Okay, let's just go with it.
I'm getting a name error for vector A.
For this one up here,
Yeah, that line right there. The vector A equals DICT. It's like a red line underneath it.
um, did you run these up here? So coming back up here, you ran the pandas and the sklearn. I mean, you don't need those for that, but you have to go through each one of these. Did each one of these work on the
Oh,
way down?
I think I missed the yeah, I missed a cell. I see.
Yeah.
Yep, I got that one. Oh, the split. Yeah, the one below that one. I put the code in the wrong area. Okay, I see what I did. Okay.
Yep. Fix it and run it again.
Yes. Sorry about that.
No, no problem. I mean, there's so much of this, it's easy to trip over it.
Okay. I'm still getting the same error.
You want to share your screen, Laura?
Yeah.
And I think I'm recording this, right? Yeah, I'm recording this. So go ahead and share your screen.
Okay. All right. I think the problem is I have the same code in two different cells.
Oh, yeah. Okay.
See,
Um,
I put the split up here, and then when you scroll down and it said remember the vocabulary, then I'm like, oh, that doesn't go there. I think
okay.
that's why.
Yeah, let's
So I'm
fix it. Let's do it like this. Scroll up
oh,
and just humor me. The import already happened. So scroll down a
mhm.
little bit. Um, run the cell with the doc stuff in it. Run this one again. It'll be instantaneous. Okay, scroll. So we're resetting the documents.
Oh, okay.
Okay. And now run this cell. Okay. Now scroll down and let's fix the code for the next one. All right. So that one requires, well, it's the last code in the chat, the vocabulary
Okay.
stuff.
Okay, I see. I'll put it in there. I'm sorry about that.
No, no, it's all right. Okay.
Okay.
And run that one.
Uh,
Great. Okay. So that's what we wanted to see. So now you're going to do, yeah, now you should be able to do this vector A1. So go ahead and run it. Okay.
okay. Okay.
All right. Do the next one, vector B. All right. And then do vector C. All right.
Okay.
And then now we're caught up.
Okay. Yes.
Okay. So I'm going to go ahead and take the screen again.
Thank you.
No problem. Hopefully you're seeing my screen at this point.
Yes.
All right. So now we're going to execute this cell here.
Mhm.
I'm going to go ahead and run that. no problems. And comparing to the solution, there's no changes to do yet. All right, so now we're going to do the term frequency for the first document and then the second document and beyond. So just go ahead and run that. That one worked as well. Now I think we have to add a little bit of code. Oh, okay. So here they're just trying to output what that looks like. So go ahead and run this one. Right, and so this is the term frequency calculation here. So we're kind of, like that process we just went through in Excel. Now we're doing it with Python code. That's just term frequency. All right, so now we're going to go through and we're going to compute the inverse document frequency, and they have a formula set up here. And notice all the inner loops and all that stuff on this one. A little bit more complicated. So I'm going to go ahead and run this. This does quite a bit of work. I'm surprised how fast that ran. That's pretty fast. Oh, and actually it's not processing anything. We're just defining the function. We just put the function in memory is all we did. Okay, so now we'll run the code that actually takes all the vectors and computes the IDF numbers. So hit the run button. Okay, and it did it. And here's the output. So this figured out all the calculations, and you see how, well, a lot of them are pretty identical, it seems. And is that what we're looking for? It looks like, yeah, that's what we're looking for. All right, moving on to the next cell. Now we're loading up another function. This computes the final TF IDF numbers, but this just defining the function for it. So then after we define the function, now we have to write this code, which is going to basically organize it into a nice looking output. Right. So I'm going to paste in that code here. Here it is in the chat, you guys. Right. Run the numbers, represent them in a data frame so it looks kind of like a spreadsheet, basically. So we'll run that. It worked. And there's the output. So this is like, okay. So I don't know if that's much faster than going through Excel, but I mean, once you have all the information organized and notice that it even kind of outputs it in an organized fashion. And notice all the numbers are basically a percentage less than 1. Right? And then that command here, the df command basically just shows the data frame. Not to confuse things, but now they're going to show us a way to do TF-IDF using scikit-learn, right? So like we haven't had enough of this for one night. Yeah, let's just go ahead and crank through it. All right, so first we're going to start with our imports. All right, so let's go ahead and run that. This should work okay because these are pretty basic libraries. Oh, and we got that. Wait, we got that same problem again. Get feature names. What was the fix? Out. Get feature names out. Okay. See, like after a while, you get a little bit of experience with it. You feel a lot more confident. All right, so we know that was a problem, so we got that. So that worked. Yes. Right, notice how it's making little tables, and that looked pretty nice. And this is kind of an interesting thing. It says the values slightly differ because sklearn uses a slightly different implementation. Interesting. So that might explain why we put stuff into Gemini before we got one answer, and then we put into right and Gemini words. Yeah, that's pretty interesting, actually. All right, so that makes me feel a little bit better then. Hey, we were following what we were told to do, so
that's right.
All right, so this one here, we have this code, and right away I can see that it's going to fail because it's got that that same issue, right? But we know it now, so we can fix it easily. So we just underscore out. All right, so let's run that. And notice it did the same calculations. And notice it really kind of went through the whole process. That was really fast, right? A lot of stuff happened because we fed in the things, it vectorized, it transformed, and then it just turned it into a data frame and we were all done. All right. They kind of go here and they start talking about document similarity, including the cosine similarity and all that stuff. Remember, cosine similarity measures the tangent angle or something like that. So basically how close the angle is. And it says the smaller the angle, the higher the cosine similarity. I assume that there's no adjustment needed here. There is not. So we should just be able to run that. All right, so that ran just fine. And then we would calculate that similarity between documents using sklearn, and I don't think that needs any tweaking either. So we should be able to just run that natively. Here it goes. And that one did the right output. Okay. Then we have a few sentences here to process. So we're just loading these into memory for the moment. So let's just go ahead and do that. There they are loaded into memory. And then we need the code that does the processing, which is this. So here it comes in the chat. All right. Notice I'm just kind of reading through the code a little bit. So we're doing the count vectorizer, n-grams of 1. Okay, breaking it into documents, importing cosine similarity, and putting it in a data frame. All right, let's give it a shot. All right, that seemed to work. All right. Mm-hmm. And we need some more code down here. There's that code. I'm trying to see, oh, okay, so here we're comparing document 1 and document 2, and here we're comparing document 2 and document 3. And so I'm kind of getting where they're pushing us now. And I think there's 4 documents. No, there's 3 documents. What's the last comparison we need to do? Well, it's document 1 and document 3, since we already did the other 2 comparisons, right? So you see the logic there? We're doing all the comparisons at once, right? So we're comparing the documents to each other and then trying to find things that are most correlated. Notice this one's got really high correlation with some stuff, you know, and I think that's kind of interesting. There's also the Jacquard similarity. This is where we do unions. And normally, I don't know if you guys remember this from the reading, you can do this stuff basically with native Python tools typically. So with this one, go ahead and just run the docs here to just load them, right? Convert them to lowercase. That's a piece of cake too. And now we would split the documents into tokens, make sure we have no duplicates. And you might want to use sets for that purpose because it eliminates the duplicates. So we use this code here to do the splitting. That should run without a problem. Then we're going to utilize this to find the common words, which is the intersection. And remember, these are very common Python commands for working with sets. Then to find the words that are in common, right? Unique words, basically. We just do a union. Joining the documents together. And then we can just do the simple mathematical calculation. And I didn't give you the union one, did I? There's the union one. And then the last one is the mathematical calculation, right? And this is kind of given information, by the way. And so now that should just run, and it gives us a 0.6, right?
Mhm.
All right. Then you're given this task here at the bottom, right? And it says you're given 4 documents, pre-process them, right? Lowercase, do the lemmatization, stop word removal, use TF-IDF to convert into vectors, find which documents are the most similar to each other, and here are the sentences. And they give you all of this. And that's a little bit of a challenge to code, right? And they're not giving you the answer on that. But if you want a challenge, I don't care if you guys complete this, and I'm recording it in the video. But you could make an attempt. Now, all the examples that we just did can lead you to this, right? It's just a matter of going through the processing of it. I'm kind of thinking it's functionally unnecessary. We got this other code to work, so let's just say that this is good. What I am going to do with this, though, is I'm going to do a save as, and I'm going to call it solved, like that. And then I'm going to embed that into my core shell. Right, so we're done with the unit 6 one. So I'm going to add it here as the solution. Right, and then if people need it, I'll have it handy rather than worrying about where the heck is it. All right, that's not working too well. And I'm just going to add a little note here. Solved version with fixes. All right, so it pays to come to the bonus session for sure.
Yes. Always, always.
Yeah, and yeah, I'm going to hide that for right now, but you guys were here doing it with me.
Yes.
And then if people get stuck, I have the solution I can share with them. So that's good. It really gives me consideration as to how I might teach this in the future, though. And I think what I might do, and I don't know how you guys feel about this, is I'm going to try more and more to have all the lectures pre-recorded, like I do with the Python class, and then we just work on the exercises and the concepts. I think that would probably be better. But this is my first time going through it, so it is what it is. Yeah. And I feel like I need to fix this file too for people. I think I'm going to do that. I think I'm going to fix it. And what am I going to fix? All those code snippets?
Yeah. The frame out or whatever, feature out.
Yeah. That was the only thing that didn't work, right?
Yeah. That was the only thing.
But I don't know if that was pasted in or not. I think it was pasted in. Yeah, that was all pasted in. No, here.
Mm. Oh.
That might be the only place it exists, though. They only give you one example. All right, so it's now updated for everybody. So if somebody hasn't started it yet, they won't get confused.
Yeah.
And I'll say, spilled my coffee. Good. Fortunately, there was very little left. Okay, so we're all good. Yeah, we got 2 unit assignments done, which is fantastic. And I think with unit 7, it's probably best that we work on it with everybody. So next time we have class, we'll probably just work on it.
Okay.
All right. Well, thank you guys both for coming. I think I'm going to call it a night here.
Yeah. Have a good
Okay.
night, and thank you so much for all the help.
Oh, no problem. And
Alrighty.
we'll see you guys soon. Watch for your
Okay.
midterm grades tomorrow.
Okay.
All
Have a
right.
good night and have a good
You too.
weekend.
Yeah. Have a good weekend.